Hello, my name is Aurora Morales. I'm here to present esoteric languages for CS 341 in the spring semester. There's quite a lot of information, so let's start. So we have three sections. So what even is an esoteric language? Most people are familiar with what a regular language is. A lot of businesses use it to provide value for their business. We have some good examples like JavaScript, Golang, F Sharp, some that we have seen in our class. They are pretty, if you're a programmer, at least a bit easy to pick up. However, esoteric languages, they take a completely different approach. They're more supposed to represent an artistic approach to what a programming language can either do or look like. So, introduction to MarioLANG. Here is a picture of what a MarioLANG source code can look like, and let's go more into what you could do. So, its syntax is composed of characters that depict the source code as if it was a Mario stage. And then Mario is also represented as an instruction pointer. And the memory that we have is an array of integers that we move across and eventually throughout the source code can output. And you could create basic console and terminal programs, just like how we did with CS111. There's no official interpreter or compiler, but the author of MarioLang has made what he thinks would be the official interpreter or compiler, but he has not made it official. There are other unofficial interpreters and compilers, and that is actually what we use in the GitHub repository that I have linked at the end. So the author is White Wolf. He's an anonymous figure within the eso-lang community. However, he has made a lot of open source contributions to other eso-lang languages that I can't pronounce because they have swear words. And the main purpose for creating MarioLang was to have fun, and it was an interpretation of what he thinks Mario would look like on source file. So you have that. And he's also currently working on MarioLang 2.0, but he started working on that in 2021, and there's been no updates since. He's quite anonymous, but he has his own section on ESO wiki, so you could look up more there. How does Mario handle memory? As mentioned before, MarioLang has one array, and if you've taken 301, you can think of this as a tape, right? So this tape, you have each cell is an integer, and you could output that integer as either a conversion ASCII or just a number. And Mario is the instruction pointer, and you move left and right. Here's hello in ASCII. So, is MarioLang static or dynamic? MarioLang is static because, as mentioned before, in that memory, we only have integers, and during runtime, we cannot change the type of that integer. We could display it differently, but it is only an integer at the end of the day. Perhaps in the future, MarioLang 2.0 can support other more dynamic data structures like strings or even other things. But yeah, it's also typically stored on the stack or heap, as we'll get into later. But the one that we have in the GitHub repository is stored on the heap. So here are the programming paradigms. MarioLang is imperative. Each command that it has in the form of an ASCII character does one thing. Everything is defined, definite, and the order of operations is defined by the programmer, making it imperative. Driving the language down further, it is also a procedural language, just like how JavaScript is a procedural language, where every time we hit a command, we have this procedure that we follow. And obviously, it's also an esoteric language. So, how does this stack to what we have learned in comparison in 341? So, MarioLang is much more abstract as other ESO-langs. It also has a clear memory model, has state, and can output to the console, just like how we did with other Python programming projects within this class. But MarioLang does not follow and support a BNF structure, and instead it's only a state management system. MarioLang also has no way to define new data structures, define new ways of outputting to the console, and it does not define new functions, just like how our other languages do here. So it's also there's nothing relational like in SQL, and um, there's also no recursion like how there is in F sharp, and there's also no concurrency like how there is in essentially all the other languages. Honorable mention to Prolog, where there is no set of rules, and the way that it's written is that there is no head and body to define code. In syntax, its syntax can be broken down into three parts. Here's the first part, which is called parts. It's the world that Mario inhibits. So we have the ground, the walls, uh, a hashtag representing an elevator, and an elevator's ending point. We have items. These items are the things that the instruction pointer could stop on. So we have move the memory pointer right and left, add one or subtract one, output or get input. That's what these items do within the world. So the instructions, we also have what to tell the instruction pointer to do, which is go right, go left, jump, stop walking, start walking the other way, and skip the next command if the current memory cell is 0. Live example, here's our GitHub repository, which has the compiler and then also the other instructions and examples we have here, but we're going to look at the sum example, which takes an input from the user. That input is not 0, we continue getting input. And then when we do finally put in 0, we sum it up. So here we move the instruction pointer right, we get input. If that input is not 0, we go down, we move the instruction pointer to the right, and then we keep on getting input. This is the loop here. Then we do another check. We go back to the last input, which should be 0 when we exit this loop. And then we check. Okay, so it really is not 0. Then we go here. Then this is the actual section of the code that does the summing. We go down. We move the instruction pointer left. If it's not 0, we accumulate. We keep on accumulating. We travel down like a Mario language does. And then we tell the instruction pointer to go right. If it's not 0, which, the sum shouldn't be 0, we keep going up. And then we finally output using this colon. Let's do a live example of it. Here we have how we run the MarioLAng. Let's put 10, 10, 10, 100, 0, and then it outputs the sum. So thank you very much for watching. In the description of this YouTube video, there's a lot more links. There's the GitHub repository link, and there's also the slides link. So I hope you enjoyed, and if you want to test out MarioLAng, feel free.